What is machine learning? Machine learning is the branch of science that, as you know, it deals with the algorithms, the systems, the performance, the specific task that you use in the form of patterns and inference. So what it is that it is rather explicitly programmed instructions. It deals with a variety of different use cases for machine learning, from image recognition to text generation. So most machine learning tasks generalize the following types: supervised learning, unsupervised learning, and reinforcement learning. Don't get afraid of these three terms. They are super easy to understand. Supervised learning is about the label data on which the model gets trained. Suppose you are training a machine learning model to predict whether a picture contains a lake or not. With supervised learning, you would train a model on a dataset of pictures where the label for each picture is yes, if it contains a lake, or no, if it does not. After training, the model will be able to take in a picture and determine whether or not it contains a lake. So, similarly, in unsupervised learning, you don't have a labeled data set on which the model will be trained. Instead of labeled data set, there will be unlabeled data that allows the model to learn relationships between data observations and pick up on underlying patterns. Most data in the world is unlabeled, which makes unsupervised learning a very useful method of machine learning. So, if we go back to the same picture data set as I earlier mentioned when describing supervised machine learning, so in case of unsupervised machine learning, you now need to assume the training data set is unlabeled. You don't have the pictures set as yes or no. Instead, you have a model that will be able to pick up on the inherent differences between pictures with a lake and pictures without a lake. For example, differences in pixel color or orientation. So, this allows the model to cluster the pictures into two separate groups. If it is possible to get large enough labeled training datasets, supervised learning is the way to go. However, it is often difficult to get fully labeled datasets, which is why many tasks require unsupervised, or you can say semi supervised learning. Semi supervised learning is basically a mixture of supervised and unsupervised learning. Deciding which type of learning method to use is only the first step towards creating a machine learning model. You also need to choose the proper model architecture for your task. And most importantly, remember that based on my experience, you need to process data into a training pipeline and then interpret the model results. Coming towards reinforcement learning, it is a machine learning approach where an AI agent learns to make decisions by interacting with an environment, and you have to make sure that trial and error are being focused to maximize cumulative rewards. It uses feedback to learn optimal behaviors without explicit instructions, making it ideal for games, robotics, and most importantly, recommendation systems as followed by Meta. Now, if we move forward, you see that there needs to be understanding what is machine learning and what is the difference between machine learning engineer and AI engineer and data scientist. If I break it down, the data science deals with gathering insights from data sets. Traditionally, data scientists have used statistical methods for gathering these insights. However, as machine learning continues to grow, it has also penetrated into the field of data science. In industry, any data scientist or AI researcher needs to have a good understanding of machine learning. Machine learning in industry has allowed us to create wonderful autonomous systems. You must be remembering WIMO, which is a associated partner of Alphabet. So what it does is the autonomous systems basically operates on cloud machine learning, and while the autonomous system continues to work in the cars, what happens behind the scene is that if it feels that the model is getting degraded, it instantly tells the information about its current situation to the cloud database where the model is trained, and then the model again upgradation and training starts. So in this way the system continues to operate, and with the operation it continues to improve itself. So if I go further on, so these systems have matched or sometimes even exceeded the best human performance in their respective fields. I give you an example of AlphaGo. It is a machine learning based system that has beaten the best human Go players in the world. In industry, any data scientist or AI researcher needs to have a good understanding of machine learning. Why? Because machine learning in industry has allowed us to create autonomous systems. And what does it mean is that autonomous systems provides you the ability to have the various sort of data sets, and on those data sets you will be performing various model trainings. I give you a good sound example that consider the whole machine learning process. There is data collection rate. So when you build autonomous systems, you have to first give the data set, and on data set that entire system trains, and then after training accuracy have been achieved most probably above 90, then you go towards testing phase. So don't be afraid. First step is about data collection. It is the process of extracting raw data sets for the machine learning task. This data can come from a variety of places, ranging from open source online resources to paid crowdsourcing. The first step of machine learning process is arguably the most important. If data you collect is poor quality or irrelevant, then the model you train will be poor quality as well. Then comes data processing and preparation. Once you have gathered the relevant data, you need to process it and make sure it is in a usable format for training a machine learning model. This includes handling missing data. So null values you need to operate it, you need to make sure that if there is a null value, it comes with nan, not a number. And then dealing with the outliers. And there are many other information that I will be processing in the upcoming videos. Next step is about the feature engineering. Based on the data set that you have selected, for instance about the heart diseases, you will choose which model architecture to use. This is one of the main tasks of industry engineers. Rather than attempting to come up with a completely novel model architecture, most tasks can be thoroughly performed with an existing architecture and combination of model architectures. If I dive further, you see about model training and data pipeline. After selecting the model architecture, you will create a data pipeline for training the model. What does it mean to create the data pipeline for training the model? This means creating a continuous stream of batched data observations to efficiently train the model. Since training can take a long time, you want your data pipeline to be as efficient as possible. What about validating the model? So for this, after training the model, you need to do model validation. And this is also done for a sufficient amount of time. I have also experienced that one needs to validate the model's performance on a held out portion of the overall dataset. This data needs to come from the same underlying distribution as the training dataset, but needs to be different data that the model has not seen before to prevent overfitting. Overfitting is just like cramming. We don't want our model to perform well in the training dataset and fails on the testing dataset. So model persistence, finally after training and validating the model's performance, you need to be able to properly save the model weights and possibly push the model to production. This means setting up a process with which new users can easily use your pre-trained model to make predictions. So in the next video, we will be diving into the NumPy